So how does the spinning ride work in the amusement park? We know that this spinning ride starts to spin at a certain speed, at a constant speed, and you can stick to the wall without falling down. So let's draw the free body diagram. Let's say this is you, the free body diagram. So the force is acting on you if you are rotating in this direction. First of all, I should have a normal force. Let's say that's the wall. That's the wall of the spinning ride. So you have a normal force. You have a friction force upwards that keeps you from not falling, and you have a force of gravity which is downwards. So that you don't fall down, then this force of friction, let's write it force of friction like that. So this force of friction should be equal to Fg. Now, there is a relation between the force of friction and the normal force. The more the objects are pushed to the ground, you can see that this friction will increase. It will be harder for the objects to move, and that's what's happening. The faster it's spinning, the more you feel yourself pushed to the wall of the spinning ride, and hence the friction increases. And let's say you are going to stay stable, not falling down. So force of friction is mu static times the normal force equals to mg. And the normal force in any circular motion, we already know that any centripetal force, it's equal to, so F centripetal in any uniform circular motion, uniform circular motion, the centripetal force is mv squared over the radius. So F normal is the centripetal force. In that case, it's mv squared over the radius equals to mg. So we can see that the mass cancels, and that's why we see that it's independent of the mass of the human who is standing in this spinning ride. We don't care about his mass. But we care about the speed and the radius. So v squared over r, it's equal to simply g over mu static. So if we know what's the coefficient of static friction between the man and the spinning ride, which can be already known depending on the type of clothes he's wearing and the wall of the spinning ride, which can be found easily, and we know what is g, then I can find a relation between the speed and the radius. So let's say the mu static, let's give some example. Let's say the mu static, it's 0.1 and the g is 10. In that case, the v squared over r, it's 10 over 0.1, which is 100. So if I have a spinning ride, let's say a spinning ride has a radius of, let's say, 2 meters. Okay, let's say the radius is 2 meters. Then v squared over r over 2, it's equal to 100. So v squared is 200. So v is square root of 200, which is 10 radical 2, which is around 14 meters per second. So if you have a spinning ride, let's say that spinning ride has a radius of 2 meters, you need to spin it at least at a speed of 14 meters per second if you want to keep yourself stick to the wall. Any speed less than that, then you are going to fall down. Thank you for watching.